In this video, we will explain what pulse repetition rate means and why it matters. It refers to the number of transmissions the echosounder sends per second. And it is important not to mix it up with other graphical adjustments. Just so you know, pulse repetition rate, ping rate, and pulses per second, PPS, all refer to the same thing. Why do fish appear in that curved shape on the echosounder screen? And what does that have to do with pulse repetition rate? The cone you see represents the transmission beam of the echosounder. Every time it appears, a new pulse has been sent. At first, only part of the fish enters into the beam, so the backscattered echo is small and appears farther from the center of the transducer. As the fish moves into the center of the cone, the backscattered echo becomes stronger and shows up larger on screen. Then, as the fish exits the beam cone, the backscattered echo gets smaller again and moves farther out until it disappears. This sequence creates the familiar arch-shaped mark we see on the screen. How does ping rate affect how fish are displayed in the echogram? Let's imagine the fish is moving at a steady speed. In the first example, the echosounder transmits at a high rate. This results in a longer, more detailed trace on screen. In the second example, the transmission rate is lower, so the fish leaves a shorter, less defined trace. In short, higher repetition equals more points equals better image resolution. Lower repetition equals fewer points equals reduced detail. This concept is known as horizontal resolution. Can we control the ping rate? To answer that, remember, the pulse repetition rate is how many pings the echosounder sends each second. And what determines that? Two things. The range you select. The speed of sound in water, about 1,500 meters per second. Because sound speed is constant in water, the only remaining adjustable available factor is the range. How do you calculate the pulse repetition rate? Here's the formula. PPS equals sound speed divided by 2 times range. We divide by 2 because the pulse must travel to the selected range and back. The speed of sound in water, about 1,500 meters per second. Let's see an example. With a range of 150 meters, the round-trip time is 0.2 seconds. If you divide 1 second by 0.2, you get 5 PPS, and the formula confirms it. Now let's double the range to 300 meters. The pulse now takes 0.4 seconds round trip. That gives you 2.5 PPS. So at 150 meters, 5 pps. At 300 meters, 2.5 pps. Double the range equals half the pps. To sum up, the maximum pps is limited by the selected range. You can reduce it, but you can't increase it beyond what the range allows. Let's try this on the Seaman echosounder. With a range set to 150 meters, click the top left button, go to Display Settings, then Echogram Data. There you'll find the current ping rate at the mouse pointer position. Important note, the processing speed of your computer's CPU can affect echosounder performance. We recommend using high-performance systems according to your echosounder model. If we now increase the range to 300 meters, you'll see the ping rate drop to 2.5 pps, just as we explained. How do you set the pulse repetition rate manually? To set a particular PPS, go to General Settings. Select Program Settings. Open the ping interval menu. There, set a new interval. For example, 0.5 seconds, which equals 2 PPS. Once you confirm, check the echogram again. You'll now see 2 PPS. Reminder, you can decrease PPS below the maximum possible for a given range, but you can't increase it above this acoustic limitation. Pulse repetition rate determines how often your echosounder sends pulses, and this directly impacts the image quality on screen. While you should not change the speed of sound in water, you can adjust your settings to get the best possible performance. Understanding this concept will help you optimize the use of your Seaman echosounder.